Okay, I just made Kelly a co-host. I think I made Kelly a
I think so. I
okay,
could unmute myself.
okay. And I'm
Oh,
gonna make
great.
Deb co-host. Deb, you should be able to unmute yourself if you need to also.
Yes, I can unmute myself.
Okay.
Slideshow.
I'm gonna shut my Outlook down because my email is blowing up today.
All right. Does that look good? You guys can.
Yep.
Okay.
Thank you.
Yeah, no problem.
Did you guys get a message that this meeting was being recorded?
I don't think so.
Okay, when I look at the record button, it says recording is in process. Select record button to manage recording. So I'll just make sure everybody knows that.
Yeah.
And I also put a message in the chat. Yeah, Brian, sorry. If you want to talk, I can unmute you, but I made it so that people couldn't unmute themselves. But I do see your message in the chat.
Yeah, maybe put the message in the chat too of this is
Okay,
being
I'll do that.
recorded.
Okay. Participants. If you are a speaker, I believe I've made you a co-host, so you should be able to unmute yourself if you need to.
Thank you. I was just checking. I'm not technically savvy, so I wanted to come on early and make sure. Did you hear me?
Yes,
Okay.
yes, I did
okay,
hear you. Sorry.
okay. That's okay. I'm going to unmute myself then again. I just wanted to make sure. Okay, thank you.
Can you hear me, Kim? Good morning.
Yes, I can hear you. Thank you.
Good. Thing is going all right out in Kansas?
Yes, absolutely. It's sunny
Good.
and the spring flowers are blooming.
Are they? Oh, gosh. Oh.
Kelly, will you put the slide back on the intro slide for now? Thank you for joining the webinar, State Radon Requirements in Multifamily Housing. We will begin shortly. I'm going to give it just another minute or two as there people are constantly still joining. Okay, well, I've got 2 minutes past 11 Central Time, so we will go ahead and get started. I see the number of participants is jumping, and I know that joining WebEx, if you don't already have it on your computer, sometimes takes a little while to get logged in. But we'll go ahead and get started. Welcome, everybody. This webinar is called State Radon Requirements in Multifamily Housing. And let's see, next slide, Kelly. Can you advance to the next slide? There we go. Okay, so
Sorry.
a few no worries. A few housekeeping items just to go over. Depending on your time zone, it's morning or afternoon, so good morning. This presentation is being recorded. So we do plan to post a video on the CRCPD YouTube site following this presentation so you can rewatch it or share it. All attendees will receive an email confirmation when the video is posted. We have likely allotted more time for this webinar than we need, and there should be plenty of time for questions and answers. All attendees are on mute, so please use chat to put in your questions and we will make sure to get to them. Though this presentation does assume that you are familiar with the FHFA radon policy, we will provide a brief summary of that policy as a review during this presentation. And the target audience to whom we are speaking today is representatives from the mortgage industry who are involved in the environmental assessment and lending processes for Fannie Mae and Freddie Mac multifamily housing. Next slide. Okay, the goals of the webinar today. By the end of today's session, participants will have an improved understanding of radon risk and the importance of testing and mitigation in multifamily housing, and an increased awareness and understanding of how state radon requirements may impact the implementation of the FHFA radon policy. Next slide. Now I want to introduce to you our speakers for today's webinar. My name is Kim Steves, and I am a technical assistant with the CRCPD, Conference of Radiation Control Program Directors. Previously, I worked for 34 years in the Kansas State Radiation Control Program before my retirement. Next speaker will be Joshua Kerber. Josh is the chairperson of the CRCPD E25 Committee on Radon, and we will talk a little bit more about that committee in just a minute. And he also is the director of the Minnesota Radon Program. Following Josh will be Robert Lewis. Robert is the manager of the Pennsylvania Radon Program. And then Maria Coons, who is the section chief for certification in the Pennsylvania Radon program. And finally, Deb Madsen, who is also with the Minnesota Radon program. Next slide. This is our agenda for our webinar today. We will first discuss radon testing and mitigation and provide information targeted towards you lenders. And then we'll go over the state radon requirements for radon in multifamily housing. And then have some discussions with Pennsylvania and Minnesota about how the enforcement process works and examples of how radon violations are addressed. And as I said, we will have time for questions and answers. You can put your questions in chat at any time. Next slide. So finally, I do want to introduce you to the CRCPD, known as Conference of Radiation Control Program Directors. Our website's listed on the slide. Please feel free to visit it at some time to learn more about us. The CRCPD is a nonprofit, non-governmental professional organization dedicated to radiation protection. Our members are directors of state radiation control programs and the staff of those programs. The CRCPD also represents the state and tribal radon programs in the United States. The CRCPD's mission is to promote consistency in addressing and resolving radiation protection issues, to encourage high standards of quality in radiation protection programs, and to provide leadership in radiation safety and education. CRCPD also provides a forum for centralized communication on radiation protection matters between the states, the federal government, between individual states and organizations. We have a number of committees and task forces to address various radiation safety issues in the CRCPD, and the members of these committees are volunteers from our general membership of state radiation control programs and radon programs. As I mentioned previously, Joshua Kerber, our next speaker, is the chairperson of the E25 Committee on Radon. This committee focuses on radon risk reduction issues and topics, and this committee is made up of members with expertise and experience in radon programs from across the nation. So I do encourage you to visit the CRCPD website and learn more about our organization. Next slide. At this time, I'm going to bring up Josh Kerber, who's going to talk to you about radon testing and mitigation and provide information specific to lenders.
All right, thanks, Kim. A point of clarification too, I don't necessarily direct the Minnesota Radon program. I am one of many very talented individuals who help run that. We're housed in the indoor air unit at the state health department. And there's more than half a dozen of us who are active in many different roles. So I'm going to talk about radon testing and mitigation and specifically get a little bit into the meat and potatoes of the standards. So next slide, please, Kelly. A little bit of background on radon. Radon is a decay that emits particles that can etch hard plastic. I use this slide in any presentation I give on radon to help make radon visible as best we can. Those little dots or bubbles you see aren't actually imperfections in plastic. It's what's left behind by the radon decay products when they emit the radiation. So if radon can etch plastic, what is it going to do to your lung cells? It can cause great harm and ultimately lung cancer. And this is a simple picture of a long-term radon test kit with a piece of plastic under 100 times magnification. Next slide. So the basics, we were requested to touch on a little bit of the basics, as not everyone on the call knows, so we'll go through these quickly. Radon, natural element in the earth. It's invisible, it's odorless, it's a radioactive gas. It comes from the soil, the natural breakdown of uranium. It causes lung cancer, and it's found in all homes and most buildings. It's just a matter of how much. It's the leading cause of lung cancer in the United States for non-smokers. And the side note is lung cancer is one of the deadliest and most preventable cancers in humans. Next. As I said, soil is the major source, though we will find radon in water in different amounts in different parts of the country, but our focus today is radon in the indoor environment, indoor air specifically. So of all those sources that are listed there, the indoor air is the problem. Next. There's no level of radon that's considered safe. We want to get it as low as we reasonably can. About 10 years ago, the World Health Organization put out a publication called the Handbook on Indoor Radon, and it's a public health perspective. And I urge anyone who has questions about the health effects and the health and medical based research to take a look at this. It's a really good document that summarizes and captures all of the research that we have up to that date. What they suggest is an international health-based standard, so to speak, of 2.7 picocuries per liter, which is a conversion from becquerels per cubic meter that they use in Europe. In the United States, we measure radon in picocuries per liter. Their suggestion is that we get radon below 2.7 in any of our living environments as well as work environments. In the United States, the US EPA many years ago set our action level at 4. That was a technology-based level. It was technology-based at the time in the late 80s. They also recommend reducing your radon in your structures to less than 2 to be safe. Next. So as I said, the second leading cause of lung cancer, and the US EPA estimates that 21,000 premature lung cancer deaths happen each year in our country. Next. This is a table of the risk from people who are exposed to radon. Many people say, well, this won't happen to me. Well, at a level of 4 picocuries in a never smoker, you have a 7 out of 1,000 chance of getting lung cancer. If this was a man-made, say, chemical, it would be highly, highly regulated, but it's not. It's from Mother Nature. And there's a lot of apathy because we can't taste it, smell it, or see it. But it is very, very deadly. And if you look at the far right-hand table, the risk of lung cancer for people who smoke versus people who never smoke is almost 10x as much. It's a synergistic effect. So it's really, lung cancer is a very big concern for not only those who smoke, but those who never smoked. Next. In order to have a radon problem in any building, you need to have 3 things. You need to have a source, which is in the soil. You need a pathway that leads from that source to the house. And then you need a driving force. Well, the pathways in most buildings, as we're talking about a house in this case, but the bigger buildings are the same as far as radon entry points. Where the concrete floor meets the wall, there's usually a crack. You have plumbing penetrations that may not be tightly sealed. We have earth and crawl spaces that may not be sealed. Also, sump baskets that do not have a lid. And then settling cracks that happen over time, but there are many more that aren't listed here. Next. Common misnomer is that I have a basement, so I'm going to have more radon. That's actually not true. The foundation type doesn't matter. So if you have a basement or slab on grade, or even a crawl space or any combination of the 3, you can still have a radon problem. Next. So your neighbors have tested, or the unit next door to you has tested low. What does that mean for you? Nothing. Really doesn't mean anything. Your radon levels are dependent upon several factors, including how you operate your home or your unit. So adjacent units will have different radon levels too. You're usually not going to see holistically the same level of radon in every unit on every floor of a building. So don't depend on your neighbor's test and whether or not to decide whether or not you should test your home. Every home should be tested. Next. We also know that radon is a pressure-driven soil gas. More than 90% of the radon we find in buildings is brought into the building through pressure differences in the air. In most cases, that means that soil gas, and radon included, is being sucked in. Okay. Next. So 3 things will causes air pressure changes in a house. We have the stack effect, and we'll discuss all 3 of these. We have the downwind draft effect or weather-related causes. And then we have the vacuum effect, and that's how we operate homes. Next. This is a picture of some masonry that's going up in a colder climate. It's only about 20 feet tall, but as you see, the plastic canopy there is protecting the masons from doing their work and giving them a little bit of heat in the colder weather. So inside that plastic shell, the air is being heated so workers can work. Well, if you notice what's happening here, the bottom half or so of that plastic shell, the air is going in. And on the top half of that part, the air is coming out. So you see the kind of pillowing out. I challenge you to check out any sort of construction enclosure like this next time, and you'll see it happening. And it doesn't happen just in the winter. It happens all year round. Next. So the chimney that we live in, we build a box, we set it on the dirt, we start to live, breathe, and sleep in the thing. It's a house or it's a building. It acts like a chimney, and the house has the ability to suck on the soil. Every house that you have sucks, believe it or not. So, and any unit of air that's going out the top of the building needs to be made up in the bottom part of the building. In many cases, we control where that air is coming from, but not all. So when the lower level of the building is sucking air in from outside, as well as from the soil, the radon is in the soil. So that's where the radon is coming in. Next. To put it another way, we can take a look at the stack effect and the neutral pressure plane of a building. In this particular case, it's a 2-story house. The bottom half of the building is drawing air in because the top half of the building is blowing air out. Warm air rises and finds the high holes in the building and it leaves. That creates the need for makeup air low in the building. Now, the taller the building, the stronger the stack effect will be. And if you have holes in the building shell high up in the building, that drives an even bigger stack effect. Next. All right, weather-related causes. Air is going to flow from areas of high pressure to low pressure. Next. So when high atmospheric pressure comes in your area, what it's actually doing is the atmosphere above you is pushing air down to the ground and into the ground. And it's pushing that air through the building as well. Our buildings are not airtight, even though we like to think they are. So rising barometric pressure will actually potentially lower radon levels in some buildings, but it's temporary. Next slide. On the flip side, when low pressure comes through an area, the atmosphere is actually drawing air up from out of the soil into the natural environment outdoors, but also into your house. So the stronger the atmospheric pressure is dropping, the more radon will actually enter in that short amount of time. Next. Wind blowing against the side of a building or over the top of a building changes the pressure dynamics within inside the structure. And it's especially apparent on hillsides. So stronger wind days, depending upon which direction the wind is blowing from, we might see different radon levels in buildings. Next. There's also something we call hydraulic pressure, or when it rains or when snow melts, you get a layer of water on the ground outside. As that layer of water sinks through the soil levels, it caps the dirt outside. So the radon that was going to normally escape to the outdoors is now being pushed down into the soil. And if the path of least resistance is now a crack or a gap into a building, now that water will actually push that soil gas into a building. Same thing can be said too if we add pavement or concrete slabs or sidewalks to adjacent parts of buildings. Well, the radon that used to naturally come out of the ground is now capped and it can't escape. So it might start to escape inside the structure. Next. Finally, the things about building occupancy and what occupants are doing. There are things in buildings that we have to make them habitable. Mechanical exhaust ventilation is one of them. We have many appliances in our buildings that we have to run and exhaust an unknown or known amount of air from the building to the outdoors. Bath fans, when we're bathing, when we're, we call them fart fans, so I'll just say it. We need bath fans, and the average bath fan in a typical residential structure is going to run about 50 CFM. Well, where's the makeup air for that 50 CFM that's getting exhausted outside? Maybe it's controlled for, it likely isn't completely controlled for, so now the house is calling for more air. Same thing is said for kitchen fans, the ones that exhaust outdoors. You have strong strong air movers in kitchens because we want to capture the heat and humidity that's coming off the cooktops. There are other exhaust ventilation appliances too. For instance, your clothes dryer. If it's properly vented, it's taking indoor air to dry the clothes and it's expelling that outside. Certain types of other combustion appliances can also use indoor air for combustion. So this is not a holistic list. Just wanted to make you aware that common appliances take indoor air and exhaust it outside. And we need to use, where's that makeup air coming from? Lower levels of the building, off from the soil. Next. All right, now we're going to get into radon testing. Just so everyone is aware, there are two types of radon test devices out there. There's short-term tests that go somewhere between usually 2 and 7 days, and then long-term tests, which goes for 3 to 12 months. In real estate transactions, we don't use long-term tests. So for the purposes of the rest of this discussion, we're going to talk about just short-term measurements. Next. This is an example of one short-term test kit. It's a pouch that has charcoal in it. When you're doing a short-term test, regardless of what exact type of short-term test device you're going to use, you need to keep exterior windows and doors closed for the duration of the test. Then after the test duration is complete, you take the kit down, seal it up, send it to the lab, and the lab will send you the results. Next. So getting into then the standards, the radon measurement standards are available for free viewing on this website. And Kim will get into a little bit of this as well. But the short of it is the national standards and the US EPA consensus-based standards call for, in multifamily housing, call for testing 100% or all ground contact units and 10% of units above the ground floor with a minimum of 1 unit tested per floor. Next. This is a very detailed document, and I wanted to go over some of the slides or some of the sections with you just to make you aware that this isn't just something that's just kind of willy-nilly put out. A lot of hard work and dedicated professionals have put this together. So in section 3, it talks about test locations, and there's the ground contact locations, which in these two illustrations are in red, and then the upper floors, which are in blue. Section 3.2, as you'll see, is what might be considered a common multifamily building, a 4-floor or 5-floor multifamily building, where we're testing every ground contact unit, those above a garage because it would be the next unit up. And then in the lobby, you'll see there's 2 test devices because it's a larger footprint room. On the next 33.6, you will see the difference between 100% ground contact and then maybe some inaccessible areas. Well, we're going to test the space above those inaccessible areas. Next. Table on the left shows the requirements for where to put test kits in a room. It's very wordy. I have a follow-up slide to this. And then 2.5 is a summary of testing procedures. It's a flow chart that you can all follow and understand exactly what the next steps are in this entire process. Next. So where in the room or where in the unit is a test device likely to be placed? Well, we want it to be in the breathing zone of the room. We want it to be representative of the air that's going to be breathed by humans. So we need to have it about 20 inches off the floor at a minimum. We want to keep it away from doors and windows, at least by 3 feet. Keep it 1 foot away from exterior walls, away from heats, drafts, humid areas. So we're not going to test a bathroom, laundry room, or kitchen. You want to test ideally a bedroom or say a family room, the room where someone spends most of their time. And then 4 ways around any other object. If you're going to suspend it or hang these test kits from the ceiling, you want to be at least a foot below the ceiling. I'd like to say 6 to 10 feet above the floor. Next. Continuing on with the standard, section 4 talks about the test conditions that are required and the HVAC ventilation and how things should be set. Next. Section 5 talks about the deployment periods. We're talking short-term test devices, so we're talking usually 2 or 3 days, maybe 4 days in real estate transactions, but it's not the only duration that you're allowed to do. And so Section 5 goes through that. Next. Section 6 talks about the things that happen during the test and maintaining closed building conditions and doing visual inspections of the property as well. Next. Section 8 talks about test reports and what you all should be seeing in the Radon test reports that are coming from Radon professionals, as far as summary reports and the essential information, and then the summary results and the next steps. Next. The section continues. If there's low radon concentrations, there's one type of radon test report. And Kelly, if you go to the next slide, it'll show what we wanted to hear or see about the reporting value of elevated radon concentrations. Yep, that's fine. You can go to the next one as well. I just want to show that there's a lot here in this section of 8 that is required to be on these professional radon test reports, including some of the attachments as well. Next. And again, this is the last part of the section 8, talks about what happens with the continuous monitors if you go there and other reporting and disclosure requirements. And then we're going to move on next to talk about a little bit of mitigation. I'll get ahead of myself here. There's also additional information available in the companions guidance at the end of this document. It has sample forms and descriptions, including building diagrams, and then also guidance for building managers. All right, next slide. Let's talk about mitigation then. You did the testing, you found out there's a problem. How do we fix it? This is a very simple schematic from the US EPA about having a multi-section point system in a 2-story house. Well, the mitigation process and principles are the same regardless of the size of the building. So we want to suck the gas out, but you want to stop it from getting into the building in the first place. That's the most successful form of mitigation. So we want to redirect the source. We do that by a series of pipes attached to a radon fan that runs continuously. It draws negative pressure from around and below the floor and blows it outside. Next. I do want to stress that mitigation is a professional level activity, especially in large buildings. There's additional training requirements and know-how on how to do this right. There's detailed system design specifications that these trained professionals need to know. They need to know how to do diagnostics and investigations and how much airflow is it going to take, how much pressure do we need to deliver in order to get adequate suction underneath the entire floor. In single family homes, a lot of companies will just install a cookie cutter radon system, and that will work a lot of the time. That will not work in big buildings. You really need a lot of applied building science. And active soil depressurization, or ASD, as it's more commonly called, is the most common solution for reducing radon in buildings. Next. And we have a standard for this as well. In this case, though, the mitigation standard starts with standards for existing homes, and it covers most everything that you'll need for the standards and how to do things. However, when you bring in multifamily and school and commercial buildings, the larger buildings, it's an add-on standard to the soil gas mitigation. So you're going to need both of these standards to look at, because the one for large buildings refers back to the one for single family homes. Next. So common question is, why can't we just seal the cracks? Well, sealing is not a standalone technique. We can try as much as we want to seal all the cracks, but there's 2 types of concrete out there. There's a concrete that has cracked, and there's concrete that will crack. So there's the cracks that will form. There's too many to find sometimes. They're not always accessible. That's why sealing is not a standalone technique. Next. So it starts with a hole in the floor. We drill a hole through the floor. Sometimes we core a hole. Sometimes we chop one out. But then once we're under the floor itself, we'll dig out 5, 10, 15, 20 gallons of fill to create a suction pit. Later, this pit will be sealed from the top and made airtight. Next. We can also use sump baskets to draw air from underneath the soil. Oftentimes these are connected to drain tile, which is shown in the next slide, Kelly. These perforated lines run around the foundation of many buildings and dump back then into one place, which is the sump basket. And they're normally not chock full of water. So if they're not full of water, they're full of soil gas. And if we can capture that soil gas while it's collected there, we're very successful at mitigating the structure. Next. Crawl spaces do need to be sealed. Sometimes we also add a suction point under the crawl space membrane to capture the soil gas that's underneath there. Next. Sealing is very important. It's not important to seal to try to keep radon out. We want to seal the gaps and cracks that we have so we can keep the conditioned air in the building. When you have lots of gaps and cracks and openings that are unsealed, it can short circuit the radon system, costing you lots of money to operate this thing long term. When we seal these gaps and cracks, it makes the radon system more efficient and far more effective. Next. In the United States, we put our radon fans outside conditioned spaces. The fan housings can leak. It's rare, but it can. And the amount of soil or the amount of radon in the soil gas is a lot higher, hundreds of times higher than what makes it into the building. And we're not continuously testing for radon. So that's why we want to keep the fan outside. And then the next slide, Kelly, is a cross section then. I'm getting ahead of myself. Then we exhaust it up through the roof. Once you get back to the standards, we'll discuss the other stuff. So it looks like a normal plumbing vent stack once it's above the roof line. Next. Here's the cross section I was referring to. So the pipe route can be either in the interior, which is shown on the left, or the exterior, which is shown on the right. But what's important here is that any pipe that's in the conditioned space of the house needs to be below the fan. And what that does is it puts it under negative pressure. So the air is going into the pipe and not blowing out of the pipe. So if there's a loose fitting or if the pipe gets punctured somehow, you're not dumping humidity and high concentrations of radon into the structure. You're actually drawing it out. Next. There are exhaust requirements, and sometimes these can get pretty complex depending upon the situation. Here's just a handful of examples. The exhaust point needs to be 10 feet above grade. It needs to be 4 feet away from windows. If it's not more than, it needs to be 10 feet away from windows if it's not more than 4 feet above it. If you're gonna put discharges, horizontal discharges on this, like an elbow, a 90-degree elbow, then you need to be 20 feet above grade. We want to be venting these things straight up, as it shows over in 6.4.9. We don't want to have any elbows on the end of these things. But if you need to get around an obstruction, that's allowed. But we do not want to allow it to blow back down onto the building, into the building anywhere. Next. There are electrical requirements that are with these systems. The systems need to be labeled. And here's some examples here on the right-hand side of the information that's required to be posted on the system itself. Next. The post-mitigation requirements, there needs to be a post-mitigation test that's conducted. And Section 9 of the Soil Gas Mitigation Standards discuss what those requirements are. Next. And maybe the most important piece for post-mitigation is Section 10, which is the OM&M, or long-term OM&M plan that's required to be not only created for the system, but also handed over at the time the system is complete. Next. There's additional information in these two documents as well, with additional exhibits and companion guidance, example forms, there's guidance for property owners, example logs and checklists. And again, that's in the companion guidance at the end of the soil gas mitigation standards. Next. Kicking it back to you then, Kim.
Okay, very good. Thank you, Josh. Next, we're going to talk about state requirements pertaining to radon and multifamily housing. So next slide, Kelly. We have about 20 states that have radon laws or regulations in place. So for those states that do not have radon laws, the policy that you likely are following is the FHFA radon policy, which you all should be familiar with. It is, this link provides where the FHFA site, where the FAQs are, and the fact sheets about the policy, and the actual policy can be found there at that link. But then also there are, as I said, about 20 states that have radon laws and regulations, which would supersede the policy. And the second link down there, the sosradon.org, will provide information about those states. Next slide. Josh has talked about the standards, so I'm not going to spend a lot of time on that. But when we talk about standards, these are the standards we're referring. The specific standards shown on the slide are for the multifamily building radon measurement and mitigation. There are other standards out there, but the ANSI ARST standards for radon are consensus-based standards which are recommended by the EPA and across the nation. The website on this slide is where these standards can be purchased, or as Josh mentioned, you can go to the website and view them for free. Next slide. These are not all, but these show some examples of the differences between the FHFA radon policy and the ANSI ARST multifamily radon standards, which I showed on the previous slide. So the standards require a certified radon professional to do the radon measurement and mitigation. The FHFA policy relies on an environmental professional. The standards require 100% of ground floor units to be tested for radon. The FHFA radon policy requires greater than or equal to 25%. The standards require a building-wide mitigation or clearance, where the FHFA policy only requires those units which have elevated radon tests to be mitigated. Both standards and the FHFA radon policy do require that state laws and regulations be followed. The FHFA radon policy also has some exemptions which are not included in the standard, such as properties which may have had previous radon testing, properties with no ground contact residential units, properties which incorporated radon-resistant building techniques during their construction, and overall, any properties can be exempted as determined to be appropriate by the environmental professional. Next slide. I also want to briefly mention the HUD radon policy. The HUD policy and the FHFA radon policy for radon are not the same. And on the slide, there is a comparison using a few examples. And as you'll see, the HUD radon policy tends to match up more close with the ANSI ARST radon standards than the FHFA radon policy. The two policies are not the same, so the lender will need to follow the appropriate policy for that loan. Next slide. There is another important point for consideration I want to provide. A state may not have a specific radon requirement or laws enacted, but a certified radon professional who is certified by a national proficiency program agrees as part of becoming certified to follow the ANSI ARST consensus-based radon standards. This may lead to a potential conflict of interest for radon professionals if they are asked to not follow the ANSI ARST multifamily measurement standards. For example, not test 100% of the ground contact units during a multifamily building radon measurement process. Though the FHFA radon policy stipulates at least 25% of the ground floor units, the radon professional is bound by his or her certification to follow the standards, which require 100% of the ground floor units. This is an important point about which all lenders and environmental professionals should be aware and understand to try to avoid placing the radon professional in a conflicted position which threatens his or her certification. Next slide. In a state which does not have radon measurement or mitigation requirements or laws, we anticipate that the lender will follow the FHFA radon policy. Please do remember that potential conflict of interest with our radon professionals that I just mentioned. Even in non-regulated states, it is recommended that the ANSI-R standards for multifamily measurement be followed, as those are the nationally accepted consensus-based standards. Next slide. So the next thing I want to talk about is those states which do have radon requirements. States which have enacted laws and or regulations pertaining to radon testing and radon mitigation, which would apply to multifamily homes. It is very important that lenders and environmental professionals and all those associated with the Fannie Mae or Freddie Mac loan process know which states have these laws, because in these states, the requirements supersede the FHFA radon policy. On this map, the states shown in orange all have radon requirements. Next slide. So this website, the sosradon.org, will take you to a link in the National Radon Program Services website where you can look up and find out the details about each state's radon laws. Next slide. There are two ways that you can look up this data. The first is to select the summary table, as I'm pointing to here. Next slide. By selecting summary table, it will open up this table. It lists the 20 states which have radon laws applying to multifamily buildings and whether they require the individual doing the radon testing to be certified, if there is a disclosure of radon results required, and if the ANSI-R's radon standards are adopted as mandatory. Next slide. If you continue scrolling down in that summary table, you will see there is specific data for each state. I'm showing the first one, California, in alphabetical order. For each state, you will be able to read a summary of the pertinent radon laws and also follow a link to read the actual law on the state's website in the state's legal language. Next slide. If you'd rather skip scrolling through a summary table and want to get to a specific state, and if you know where it is on the map, you can just click on the state of interest. In this example, I'm clicking on Kansas. Next slide. By clicking on the Kansas, a window opens which provides the same detailed information about the state's radon laws and regulations that was in the summary table. It includes the summary of the laws and direct links to that state's laws, so you can read the actual wording of the law or regulation yourself. So at this website on the sosradon.org, you have two different ways to look up the requirements for multifamily radon measurement in each of the 20 states which have those laws. And you can see a summary and also be taken directly to that state's laws. This information obviously evolves regularly, and this information will be updated on a regular basis on this website as state requirements change. Next slide. This is a key message of this webinar. The states are aware of the FHFA radon policy. Those states with radon laws and regulations of their own are watching and verifying that their radon laws are being followed. Use the data we are providing to ensure that you know which states have laws and what the state laws require. Next slide. Okay, at this time, I'm going to turn it over to Robert Lewis and Maria Coons to discuss their Pennsylvania enforcement process.
Okay, Kelly, you can go to the next slide, please. Good afternoon, everybody. My name is Bob Lewis, the Radon Program Manager for Pennsylvania, and Maria Coons is here, my colleague, with you. We're presenting to you today from Harrisburg, Pennsylvania, where we work for the Department of Environmental Protection and the Bureau of Radiation Protection to give you some of the information that's available for PA as far as radon testing and multifamily and mitigation requirements goes. We only have about 8 or 9 slides, so we'll fairly brief. Kelly, next slide, please. I should point out that our radon certification regulations have been in place since the early 1990s. However, it was just recently, as you can see, January 2019, that we added the ANSI-R standards for both radon testing and mitigation to our regulations. And in the next 2 slides, we'll just basically show you the versions of those documents that we have currently adopted here as of 2019 at least. Okay. This is the multifamily testing document, NCR's MAMF 2017. I will point out that there's a little difference here between what Josh and Kim showed you. This is an earlier version here. This is what we currently have in the regulations and have not updated this yet. So we are using the 2017 version of the testing document. And I don't believe there's significant differences between the updated versions as well as this. So for the time being, we're comfortable with staying with this. And then the next slide shows you the mitigation NCR standard, and that's dated 2014 as well. And there are additional newer documents from that. I'll just, that's okay. You can go to the next slide. Yeah, that's pretty right here is fine. In Pennsylvania, we do have reporting requirements for all of the testers, the laboratories, or the radon mitigation contractors. They are all required to report all their activities to us, the mitigation, where it's occurred, what type of mitigation system, testing, test results, where it occurred in the house, the basement, the type of house, and so forth. But just until recently, these are some of the codes you see here for whether it's reported to us, and the house type codes. We have never had originally, we did not have any coding for multifamily testing. We had other codes for 2-story, 3-story, ranch, commercial buildings, etc. So that was just an additional code we just recently added within the last couple of months. I don't remember what the number is, but it's maybe 560 or something. So when one of our testers or mitigators is out there doing work in a multifamily house, and they will report that to us as a multifamily building under the appropriate code. So that just helps us to go back and query these different things to see how many multifamily buildings have been tested and so forth. I think this has been going over a little bit already, but I'll just go over it anyway, since it's sort of important to reinforce, I think, and reinforce the government-sponsored enterprises. Basically, there's 2 slides here, what they do require and what they don't require. As it's already been said, what they do require, or what they're asking for, is testing 25% of the ground contact occupied units. They require the environmental professional to manage the radon testing. They do provide that the tenant notifications be given to the tenants prior to the testing, so the tenants are aware that this particular activity is going to take place. And they also require, which is fortunate, that they comply with any applicable local radon laws and or state regulations. And as we just showed you, in Pennsylvania, there are laws and regulations that govern testing and mitigation in multifamily buildings. And the next slide shows you what they don't require. What they don't require is what we do require. They don't require 100% ground contact occupied units all be tested. They don't require an adherence to the current or the even older versions of the NCR's radon testing and mitigation standards, nor do they require the use of a state certified or nationally listed professional. And then I go to the verse and say that we do in Pennsylvania require all 3 of these things to occur. Obviously, these are just going to a little higher standard and making sure all units are tested, and they're using the most current standards to get the best possible test results for the occupants of a multifamily structure. The next slide. Let's see, is it still me, Maria? Oh, I should say too, that because we recently became aware of this discrepancy with the FHFA, we wrote out or typed out an email, I should say, to all of our industry folks advising them of this, so that and we have been getting more calls and so forth from a lot of the environmental companies coming into Pennsylvania, wanting to contract with one of our certified testers or mitigators to do work in the multifamily buildings. So we wanted to make sure that our certified testing community was aware that they still need to follow the regulations that are in place for Pennsylvania. And we're quite confident that they do indeed know that. So they know that they have to follow the NCR's testing and mitigation standards, which require those previous 3 or 4 or 5 items that I previously mentioned. And I think just the next 2 slides, Maria will go over as I think here. Let's see here. I think that let you go over that, Maria. Thank you.
That's me. Hi, everyone. I am Maria Coons. As Bob said, I work under him in the Radon Division of Pennsylvania DEP. I'm the supervisor of the certification section. So in that section, we oversee enforcement. So going over what Bob had briefly, deviations, so that you know, the deviations from the Pennsylvania regulations, which includes the ANSI-R standards for multifamily radon testing and mitigation, may result in penalties of $6,000 or more. Enforcement actions could result from not testing 100% ground contact or not employing a Pennsylvania DEP certified professional. There are also could be additional penalties for failure to perform required health insurance and for a number of tests performed if the individual is not certified. DP has become much more aware of multifamily testing in Pennsylvania since the FHFA policy, and is beginning to focus on ensuring that the anti-arst multifamily standards are followed. Next slide, please. Just to give a brief overview of Pennsylvania's DEP's enforcement process. Enforcement begins with a notice of violation or NOV, which requires a written response from the recipient. Based on the response, an NOV is followed by another legal document called a notice of proposed civil penalty assessment and call to conference. This document contains a calculated proposed penalty and a request to schedule a conference call to discuss the violation and the terms of paying the penalty amount. Lastly, a consent assessment of civil penalty or CACP is prepared with the terms agreed upon during the conference call. This legal document is signed by the individual, business entity, or agency in violation, a representative of DEP and DEP's legal counsel. Thank you for your time and attention. Bob Lewis, Radon Division's Program Manager. My email addresses will be available at the end of the webinar if anyone has any follow-up questions after the webinar is completed. I'll turn this over to Deb Benson. Thank you so much.
Good morning, everyone. My name is Deb Matson. I am a radon specialist with the Minnesota Department of Health, and I'm going to talk a little bit about our enforcement process in Minnesota. You can skip ahead 2 slides, Kelly. So today, the intention of the presentation is to talk about our enforcement process, but I do want to take a moment to say that a lot of our efforts is to help our licensees comply, to make it easier to comply with the standards and make sure that good testing is being done in Minnesota. We offer education to our licensees. We've developed templates for the multifamily testing and stuff so that they can more easily comply with those requirements that Josh went over earlier. So for our enforcement process, we review stuff in a number of ways. We routinely do audits of our licensees to review their processes, their paperwork. For mitigation, we do go out and do physical inspections of the system and then check kind of the documentation. We do various investigations to see if unlicensed work is going on in the state. And then folks can submit complaints to us if they see improper testing, unlicensed testing, and we investigate all of those. And then if we do identify violations during that process, we proceed to the enforcement process. So Kelly, do you want to advance? So we've got it broken up in Minnesota that your first offense is basically a legal letter that we call a correction order. And that is a documentation of the violations found. There are not penalty orders associated with that as long as you come into compliance. And then that's the licensee is requested to come into compliance within 30 days. Kelly, next slide. And then for a second offense, we've told them that they were in violation. We help them come into compliance to correct it. If they repeat that violation within 5 years, then there are monetary fines issued, and those could be forgivable or non-forgivable depending on what the violations and how often those have been repeated. There are times that we go right to the administrative penalty order, and that is for folks who are doing unlicensed testing. If they are using unapproved testing devices, and then on the mitigation systems, if they don't have a Minnesota issued tag on the system, in those cases, we go right to administrative penalty orders, and there is a fine associated with that. Kelly, next slide. So what do we consider serious violations? It is disregard for the requirements, like failure to have a license, failure to comply with our requests to do an audit or to provide us information, and then failure to make corrections. Like I said, we give folks a letter saying, hey, this is what you need to correct. And if they disregard that and don't come into compliance, additional action can be taken. And then violations that present an actual or potential danger to public health or natural resource. And that can be testing in the wrong place. It could be not testing 100% in like multifamily large buildings, because those can vary depending on unit to unit. So we want to make sure that we get that done properly. Failure to communicate hazards, failure to maintain and calibrate testing equipment, do your quality control measurements, etc. Next slide. And then for fines, some of those fines, if it's not serious, not a repeat, those are forgiven within 30 days. So you come into compliance, you don't have to pay the fine. And then we do have non-forgivable fines. So like if you're testing without a license, that is a non-forgivable fine. Licensing has been around in Minnesota since January 2019. We've made extensive effort to educate everyone in Minnesota that it is required. So that is non-forgivable fine right off the bat. Next slide. And then some examples that we have seen in Minnesota for our multifamily testing. We have had individuals who have been testing without a license. In some states or other parts, they may allow folks who are associated with the company maybe to do testing of that building. In Minnesota, you can't. We have an exception for an individual who owns a building. They can test their own home without a license, but if it's owned by a corporation or something, they have to use licensed pros. So in this case, it was a multifamily building. They had the property management company do the testing. We found out about that, and so we did take enforcement and to come into compliance. In this case, the guy's like, I'm never going to test again, but there was still a fine associated with that. Not testing all locations. We have seen that multiple times. Licensees are required to submit all of their test data to us. We take a look at that. And then when I audit, I have folks send me test reports, maps, talk about them. So when they are not testing in all locations, they do get enforcement action, and they need to have a plan in place to ensure that they are going to do proper testing in the future. We have had cases where folks aren't doing their quality control, like their duplicates, blanks, and spikes, so that they can't ensure that those test results they give the client are accurate. And so again, we've done enforcement on those cases. And then sometimes there is significant kind of documentation of what needs to be communicated to the client so they understand the risks involved with their results, and they can use those to make good health decisions. So when I review those reports and stuff, if that is not in there, we have taken enforcement action on that. And I believe that's my last slide, Kelly, but if you want to go ahead and advance.
Okay, go ahead to the next slide, Kelly. These are the websites, kind of references for things that we talked about today. The first is the link to your FHFA radon policy and all of their frequently asked questions and fact sheets about their policy. The second one, the sosradon.org, we encourage you to bookmark that site. And anytime that there's any kind of Fannie Mae or Freddie Mac business being done in one of the states that is regulatory, be sure that you are aware of the laws and requirements in that state, which you will be able to find at that website. The arst.org, that is where you can go to find the ANSI ARST consensus-based radon standards. You can view them for free online, and that is the Indoor Environment Association. And then the final one is the Conference of Radiation Control Program Directors, CRCPD. I definitely encourage you to visit that site and learn a little bit more about our organization. Next slide. Okay, this is our contact information. You're certainly welcome to email any of us. As I said, I'm Kim Steves, and I will send an email out to all attendees once we've been able to post this webinar to our YouTube site so that you can view it again or as needed. At this time, I'm going to take a look at the chat and just see if we have any questions in there that haven't been answered. Scrolling through the chat, we did have a question about viewing the slides. As I said, we're going to post that on our YouTube site. There was a clarification from the National Radon Program Services from Christina saying the summary table PDF has bookmarks which appear if you click on the upper left corner of the online PDF to help navigate to the specific states. So another way when you're looking at that summary table information to get there. If anybody has any questions, now is the time to enter them in the chat. And I will open up to the speakers. If there's any final comments or anything you want to say or that you forgot to mention, you're welcome to speak up now. I've got a question here. Going back to the conflicts of interest, if a state doesn't have radon regulations, ANSI should be used. But before using that standard, should we first use the FHFA guidelines to determine if we should do any testing and then use the ANSI standards to conduct the testing? Josh, do you want to take that?
Sure, I can take a approach. I would actually suggest that the FHA guidelines to determine if you should test. I don't believe that the guidelines actually dictate whether or not you should test. I think we're all here in agreement that says, yes, you should test, and you should be using the ANSI standards in order to conduct that testing. The one thing you don't want to use is a map or a table to determine whether or not you're in a quote unquote zone that may or may not be high or low in radon. Every building really needs to be tested. And the reason for that is, one, we're finding high radon levels even in low, quote unquote, low radon level areas. But two, when we're not testing 100% ground contact in any building, we're leaving a very big portion of the population behind. So not only are we leaving people behind where they can't control their radon exposure, like renters, low-income renters in many cases, it's a health equity issue as well. So that's why we implore you guys to just follow the ANSI standards and do the right thing right away.
Thank you. Any other questions? I'm not seeing any pop up. You do have here our email addresses, so please feel free, if you have a specific question for any speaker, feel free to email the speaker. We'll give it one more minute to see if any more questions pop in, and then we will go ahead and end the webinar a little early. I thought we might get done early. We do have a question. How often will we be hosting these webinars? We kind of put them together on an as-needed basis when issues come up. So if any particular issue or question comes up that you would like more information on dealing with radon, radiation protection, please don't hesitate to contact me. And I have your whole email list, and one of the parts of registration was asking if you wanted to be contacted when we do future training events. Some people said yes, some people said no, but all those people that said yes, I have your email address, and I will certainly let you know when we do additional training events. Okay, with that, I'm going to stop recording, and I think we'll go ahead and end the webinar. Thank you for your time.